linked list. In this video, we will be talking about another data structure called linked list. Previously, we talked about array, which is also called data structure, DS. In simple terms, we can say DS, data structure. Now, after learning data structure, which is place where we store values. Now we already have array, then why we need linked list? What is the need of this linked list when we already have array where we efficiently we are storing array, values. So let me show you how we store value in array. So this is one array. Inside this we store values like 1, 2, 3 and 4. Okay, in simple term. Now the problem here it was that we were storing values consecutively, means one after one to its adjacent. Like let's say for example, when we run a code, our everything gets stored in RAM, right? This is RAM. Sorry. Let's say for example, this is one RAM. Here, what happens? Here we have one stack, then again the second stack, then third stack, then fourth stack, like that, and each one is divided like this. Everywhere we store a value. Now when we generate an array, so what the compiler does, or what in the runtime what it happens, they this code tries to find out a place in where this compartment, the stores are consecutively ordered. Like if let's say for example here something is there like na something e, some values are here already present, so they cannot allocate this place to array. They need a place where consecutively places are vacant. Now they can, now here they can the code can access this place. Okay, but they cannot access this place because we already have a place which is not vacant in between. Now this was the problem, that we are unable to get a place where the middle page is not vacant. We need a place where there is the whole area, the wanted area is fully vacant. We want that one to get array. That's the problem. Here we can simply store 1, 2, 3, 4. Now this is what array is. Now what happens in linked list? Linked list something looks like this. Linked list will look like this. It stores in node part. This is one box. Here it will store 1. Then this box will point to another box. Now in this box it will store 2. Then this will store another box. Here it will store 3. Then again another box, it will store 4. Now this is how a linked list stores. Okay. Now this is what linked list stores. Cool. So how this is being implemented in RAM? Now that's you need to understand that one. Okay. Now you should not leave that. Now let me tell you that one. See, let's say we have this RAM. Now these all spaces are not vacant, occupied. Now these places are vacant, right? These are vacant. So we are going to utilize those because we have spaces, right? So here what we're going to do, here we'll write 1 in linked list 1. Then here you will write 1 and we'll store one value like the address of next value. Now this is the address, its address. Here we are storing 2. So after 1 we have 2. So in this, in one node in one node, this part here, for example, let's say this part here, there will be, we will store 2 values. 1 is data, 2 is address of next pointer, next box. So address of this box we are going to store here. So 2, then here we are going to store the value of 2 and the address of next value. So here 2, then here we have 3. So address of this box we can store here as well, or here as well, but we are going to store the value of that box inside this 2. Also this, because there are 2 variables inside this box. The one is data and one is address. data is 2, address of this 3, then 4. Similar here, you're going to store the data and the plus address of this box. So this is how we use, this is how, see how efficient it is. We have occupied all those non-vacant which were vacant, sorry, which were vacant, we utilize those, and we have efficiently stored our value as well. Now there is another way, another one more thing, example, why we have used linked list as well. Let's say for example, this is linked list, okay, Viswa, this is linked, okay, this is linked list, and this is array. If I ask 1 2 3 4 and let's say 7, if I ask you to put 5 in between, now 5 will come over here, okay, let's say 5 comes here. So what are you going to do? You're going to shift this, like for example, let's say here we have 4 4 5 6. Now we want to put 3 after 2. How we are going to do? For that we need to shift all this to next place. So this will get 5, this will become 5, 6 will need to remove, then this will become 4, then this will become uh, then this will become 5, this will become 6, this will become 4, like 3, and this will become 4 5, like that. Only then we need to shift one by one. Now that's very much time taken. So in this place, what are we gonna do? We'll create another one. What we'll do, we'll generate one more box where we'll put the value 3, and we will point this value. Now I'll ask this pointer, this box to point to this box and delete this, and then we'll ask this box to point this and delete this. See how simple it is. It's very simple to tell that a box to point this box, and then then ask the three box number 3 to point the 4 box. And that's how linked list works. And there is, at last it will point to null. Here we call it tail, and this is called head. Head is the first variable, sorry, first box is called head, and the last value where it points to null is called tail. Okay, so now if you want to add something, then something will get add here, then again it will point to null, then we will point, it will add something, then it will be add here, then null, like that. I think it becomes very easy and more efficient like that. Actually, what was that? This is linked list. Okay, we have 1 2 3 and 4. Now we will take this one node. This is called node. Okay, this is called node. This first node is called head, and the last node is called tail. This points to null. Cool. This is the whole thing of linked list. The only thing you need to remember here is that why we need this linked list. We need this linked list because we need to store the data non like adjacent way. Like we do not want to store data in consecutive way in our RAM. That's the one thing. Then this is something that helps us to like efficiently store the data in multiple location in the RAM. That's the main reason why we need this linked list. Okay, this is the reason why we have also that one. Okay, now what we're gonna do is like for example, we'll take this one node, we'll take this node and we'll check what it contains. In this one node we have the data called 1. This is data, we have 1, and we have address of next node means address of this. Okay, address of this, we have this address of this, no, box 2 will store that. So the address type will be, the type of address will be node, because we are storing a node address. So the data type of that address will be node. Okay, we are going to now the first thing we are going to do, we will create a node class. How to create a node class? Yes, and two, we'll see how to use node class and to create linked list. Okay, LL means linked list. We'll see these two things. Cool. Let's say here we already have our node thing. Okay, so let me delete this one. Yes, delete it. Okay, now I'll show you from scratch. See, here we have first create a node class called node because we need a node type. Okay, we created a node. Inside the node, what we have? Inside the node, we have data and the address of next one. Address of next one, we have that one. That data type will be node. Okay, so int, we are storing integer value called data and node type called next. Means address in the sense next. Now you'll ask me, the question you'll ask me is this. Okay, at this point, I have mentioned node. Why we have mentioned node? Why not int? We have talked about that, right? We are going to store a value of node address. We are storing a node address, which is next box in this variable. So the data type should be node. Okay. So now what we're going to do? We go to man, and we'll create an object of node. Node first box we are creating, first node we are creating equal to new node. Then we'll say first dot data is equal to 1. Okay, so that value, this should be data. I am making it because to make it easy to type for me. Then node second is equal to new node. Cool. Sec dot data is equal to 2. Then node third, new node 30HIRD is equal to 3. Third, okay. So now you'll ask me, like, why we are creating the object every day? Yeah, we need to create that one. Now to create a box like that node, we are creating this node. This is 1, this is 2, this is 3. Here right now we have not made, we have just created this part. We have just created this. What we have done there, we created a box, we named 1, we created another box, we named 2, we created another box in random place, named 3. Now we have not linked it, we have not linked it. Still this is pending. Now how we are going to link that? It's very easy. In that linking in this point, what will go, first dot next is equal to sec dot next equal to third. This can also work, and what you can do, you can do first dot next equal to third dot next is equal to next second. You can do that as well. Now this is how you need to link that. Now after writing that first dot next equal to second, we did like this. We pointed like this. Then second dot next equal to third, we pointed like this. This is how it worked. And now we'll show. So and at last, this will, if nothing, if a value, if a node is not pointing to anything, then it is pointing to null. Okay, this is head. And do remember one thing, it's very important. You cannot traverse randomly from the second node itself. Cannot traverse a linked list. Means you cannot traverse 1, 2, 3 like in array in linked list from the mid of this node, from middle node. You need to start from the head itself. Head means this first node. Why? Because this is the node where we have stored the next node data. The next node data. Here we have the next node data. It will start from here. From here only you'll get the node which is connected to the first node, means this one, and then here we'll know the node which is connected, which is our third node. Now you'll go like that, it will go. We cannot directly jump here, we cannot do that because we do not have the address of this data, right? We have the no we have the data of this one. Okay, this is the best practice what we can do. Okay, to traverse we need to start from the head itself, not from mid or anything from no, from the last also we cannot. For if you want to start from the last, you need to have doubly linked list. We have the type called doubly linked. It means we will link we will point from 2 to 3 and from 3 to 2 as well. That is also a type of linked list we have. In future we'll learn that one as well. In types of linked list we'll learn that one. Okay. So for traversing, what we're going to do, we'll use a while loop because we do not know when it is ending. We do not have the length of this. We cannot say the linked list dot size, or we do not have that one. Till we go to the null part, means when the last node, this last node, when the last node is pointing to null, at that point we need to break. So we'll use a while loop. At that, in this such situation, we use while loop. While we'll create another node. We'll create a node is equal to new node which will point to our first node. Hence node dot next is equal to first. Means what we are doing, we are creating a node here. We also do not know the address of this node, right? We do not have that node. We do not have this node because nothing is pointing to this. So we do not have this node. So what we are going to do, we create a new node, our node, and we will point to this one. After, when we will point this one, node dot next is this one. So we got this. Then from this next is this one. Then from here this one. Like that we're gonna do. That's why we need to start from the first. We need to start from the first node. We do not go to any middle node because it will break the flow. First dot first. Okay. So now what we're gonna do is while node dot next, while node dot next node is not equal to null, south node dot data, and at incrementing it, node dot next node is equal to, understand this what I am doing. After incrementing, after printing that value, what I am doing, after putting this value, I am jumping. Like, then what I am doing, node this value node dot next, the address, I am changing the address of this. Then node dot address, now it is pointing to this one. So after printing this value, what I am doing, okay, break this one, and now node dot next is this. Once I print this one, break this value, then node dot next is this. After printing this one, the node value will null. Once the node value is null, then check while node is equal to null, while node is not equal to null, then run this. Now node is equal to null, so this will become false. Once this become false, it'll jump out of this. Now run it. See, 0 1 2 3. Okay, so that node value is also getting printed. Okay, cool. Here simply we can do like this: node equal to first and one sprint, then that node value won't come. Then 0 is the node value. Okay, now 1 2 3. This what it works. We talked about traversing a linked list. Now we'll be talking about how to insert and delete a node in linked list. Okay, so there is one more second reason why we have linked list than array. Like in linked list, first thing is we are storing values in the RAM in separate places. Like there is no consecutive constant spaces we are finding inside RAM to store linked list value. And also we are making the linked list like insertion and deletion in constant time. Now, for example, let's say there are two ways we can insert a node inside linked list. So the first way is insert node in starting in the sense here we are inserting something. Okay, right now it's 23, then 1 2 3 4. Okay, then the second way, insert node in middle. Okay, so let's say first we will see how to insert a node in the beginning, in the first year. So the thing is, first you need to create a node, create a new node. Then two, after that assign data. Then third, node dot next. So at that point, what we are going to do, we are going to give the address of this head. Right now, this is the place from where we need to begin. We need to traverse the node whole linked list. So we are going to create a node and we are going to assign 22 to it, and we are going to add an address of this node like this. So now what happens after doing that, at this point, this head, this will get switched to this. Now our new head is this, 22 is our new head. So this is how it works. Okay, so now you'll ask me, okay, this is how we insert a node in the beginning in linked list. Then how we insert a node in the middle. Now this is this is the theory part. After that, I'll be explaining you the coding as well. So for that, what am I going to do? For middle part, in middle, same thing, same process. For that, what now you'll tell me, okay, if we say we create a node, then we assign a value and node dot next. So for that we need to travel to get the node dot next. Or let's say for example we want to put a node, let's say this is node 25, we want between 2 and 3. Okay, so for that, what we need to traverse from here. We'll start from 22, then 23, then 21 2. After that, what are we gonna do? We'll ask this 2 to point this node, and after we need to break this node, and we'll ask 25 to that node dot next to this. So now this is came middle. Okay, that's fine. Now for that, what is happening? For that, we need to traverse from here, then here, then here, here. After that, here we are telling this node dot next is now 25, and after that, the 25 dot next is 23. This is what is happening. But as beginning, I told our insertion is big O of 1 constant. Now how is that happening? Now it is first what we are going to do, we are doing this traversing. This is big O of n. Then after that, inserting this one, this is big O of 1. So in total, when we plus it, total is big O of 1. Then how we are telling this? How in textbook and everywhere it is written big O of 1? How it is possible? So I'll tell you how this is possible. So let me show you this. This is one linked list. 1 2 4 and 5. We want to add a node here. So let's say for example we have a current node. We have a node which is called random node. We have name is as current, and we are pointing this to this node. Okay, for example we are pointing it this way. The first traverser is to find where we have added this one. Let's say for example we are adding in between. Here we need to add. So what are we gonna do? Okay, fine. So now what is happening here? Our insertion is constant. Make sure of that. Our traversing, we are not adding that one. Traversing is a different part, and insertion is a different part here. So what do I will do? If we have a current value, where if a node whose value we are is same to this node. Okay, now we are pointing to this, and after that this is pointing to this, and from here also we can traverse, and from here also we can traverse. From two ways we can traverse, from here and here, same thing. Okay, so this is the value of this is xyz, whatever it is. it can be 0 or whatever it is, but the next value is 2, this node. Okay, remember this thing. Remember this, the current dot next is equal to 2, this node 2. Remember this thing. Okay, so what we are gonna do, we'll now we want to insert a node 3. We have created a node and given a data 3, and next value is null currently of this. Now what we will do, we will put the next value as current. We'll try to point this one current. So what we can also do, we want this value to point to this too. No, sorry, we need to try to point this value to this value, try to point this value to this. So what we'll be doing, current dot next is this, and this dot next is this. Understood? See, current 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 node dot next is, this is 2, and dot again next from next is, let's say for example, current dot next is 2, and that 2 node dot next is 4. So what is happening here is current dot next is 4, node 4. So that's what we are going to do. So this 3 node 3 dot next is equal to current, this current node, remove this one, let's remove this one, no need of this. This current node dot next. So it will point directly to this. Means I'll tell I want this node to point 4. So what I'm going to do, I'll do current dot next. So pointing this one. Now what I will be doing is I'll make this node, this 2 node to point 3. So how will you do? I will do current dot next, this is 2. So to get this node, what I'll be doing, I'll do current dot next, which is node 2, is equal to hmm, okay, wait. We have made this as node. Okay, so what was that? While creating this node, we have named it like in that object we have created node, new node equal to node. Like this we created. Then new node dot data is equal to 3. So the node, this node name is new node. So what are you going to do? Current dot next means this dot next 2 is equal to new node. We can do that. So what will happen? This will point to this. This will point to this. So now what happened? This will get removed. 2 is pointing to this, and this is pointing to this. So now 3 is in between. Like now how it will look? Now it will look like this. Now it will look like 1, then 2, then 3 here, then 4, then we have 5. Now it will look like this. Now it happened like that. So this is how insertion happened. And that point where we have a node which is already pointing to this, and we are, with help of this node, we are inserting a value. That's where this thing comes to the picture. That's where this is becomes big O of 1. Okay, so for example, what we are going to do, we will create a new node, point 1, create a new node. Before that we need to have a current node pointing to a node for insertion. insertion, where we need to point at that current node. We need to point the current node before that node where we need to insert. Now we are inserting between 2 and 4, so we need to point that current node in the 2, the before of that node where we need to insert. Means here we need to insert that before node is this 2, so we need to point that current node here. So after doing that, pointing that node, we will create a new node, current node, new node, and add data to it, as 2 or whatever it is. Then what we need to do, then third, that node, like we'll do new node dot next is equal to current node, current dot next. Cool. After that, 4, what is that? That current dot next is equal to new node. See, now try to understand this thing, these two processes you need to understand. Okay, this is where most of the people get confused or not. Now this is very simple to guess that one. Okay, this is the whole the process. Okay, this is what insertion is. Now for deletion, what we're going to do is for deletion that's the same thing. For deleting this one, let's say for example we need to delete this one, so we'll traverse from there. We'll go to this start from there here, and what are we going to do? First we need to put, now this is the head, this is the head, right? So first we need to remove that. We need to make sure that this head becomes this. So head is equal to um, this node, means our node. While traversing, do not traverse with see what we do. First of all, we need, while traversing anywhere we'll traverse, we'll need to create a node, like any node, example node, for to that helps us to manipulate other nodes. We do not manipulate the node directly. We'll create a new reference node, and we will tell this node equal to head. Okay, so which will directly point to this. Okay, now then we'll do this node dot next to traverse this, then this, it will point this, then we'll make some changes here, then it will point to this node, then this node, like node equal node dot next. We'll traverse like that. While loop we'll use, while traversing in linked list we use while loop. While this node is equal to null, when it will point to null, then we'll stop. So here once it will point at this point, when it will point, we'll tell that okay, so we want to delete this one. So what I'm going to do, I'll do head is equal to this node dot next, means node dot next here. So this head will point here. Now this will get removed. So now what we can do is, now to make this value, now we need to remove this one, we'll point this value to null. So node dot next is equal to null. So basically head is equal to, so we have made head is equal to node dot next. Now pointing node is here, then node dot next and its next is pointing to null. So now this got removed and this is pointing to null. So it will start from here. Now traversing starts from here. For what we can say, for deleting this 3, what we can do, for deleting this 3, we will traverse this node till 2. When it will point to 2, then this node, the same process what we do, where we had done. Now we'll do node dot next node now this is very simple. What we're gonna do, node dot next node dot next will directly ask this node to point here. Remove this one. So node dot next is equal to node dot next, means this next dot next, then next. So it will directly point to here. Node dot next is this, then this dot next is this, then this is now is this. It will try to point. Yeah. Or simply if you try to point this one also, it will work. Fine. Dot. You just need to play with dot next, next, next. That's where it is the result. Max to max. So you'll ask me every time we need to use this dot next, next, next. No, max to max you will use the next 3 times. That's it. 32 or 2 times, like that. It depends on that. You need to understand, try to understand this part, okay, and this will make clear to you. Now after that, what is there? Now this is what the insertion and deletion. Then we have two more things to explore. You need to explore this part as well. We have this is one node, 1 2 3 4. This is one way of linked list. Now it is traversing this way. We can also do like this traversing. This is doubly linked list. Okay, this is doubly linked list. We also have this one, single linked list. See, this is single linked list, one way traversal, and this is doubly linked list. Okay, so this is how it also. Here what happens in each node we have like this, like in data, in data, in next, and int. Sorry, not int. This two will be node next, hence this next, and node previous. So at single node we are putting in, let's say for example this node we are putting the data is equal to 2, and next node, which is node 3, address of node 3, and previous node is node 1. So now the same thing, we are traversing how we were deleting traversing that way. Now what we can do, now it's become very simple. You can traverse from backwards and you can traverse forward. This is what it is. Then that's how it works. You can also traverse from this way. Now this is the head and this is also null. Pointing, this is also head and this is also null. And traversing like that, each and each other like this. So you need to just think like that as well. You know to.
Now you look into the technical part, the coding part of it, like insertion and deletion of coding. What we have gone through, like traversal part already. Now we will be typing, like coding for how to inserting a node in the beginning and the middle, and how to delete a node from the beginning and the middle. Now we'll see that one now. Cool. Okay. See, this is here we have this part. We have created nodes. Then this is the part where we have linked the nodes, and we have, see, one, there is the very important thing. When you are traversing, when you will traverse, see, for example, let's say we have it like this. Let's say for example, if you are traversing an list, then you'll start from the head itself. So we are not asking you, or as a professional, or while you are working on linked list, you should not traverse through using head, like head dot next. No, you're not traversing like that. What you are going to do for traversing, you need to create a node. That node will take as a reference. For example, this is a node I have created, name as node here, and what I have done, I have given it to first. Means I'm pointing this, I'm making it equal to the first node, node 1. That node, I'm making it equal. Okay, but this is not the first node, right? So this is the reference of it. Now all the value that first node contains, now it's inside this node as well. Means node dot next is second here. Now as that node, this first dot next is second, so now node dot next is also second, because we have given equal to first. That's the reason. Okay, so now what I am going to do, I will use this node to traverse the linked list. Okay, see here, while node is not equal to null, but still, until this node goes till the end of this linked list, because the end of linked list is always null. Like the end node, the last node in the linked list is always points to a null. So until and unless it becomes that last node dot next, which is null, run this and print the all node data. See, that's what happening. If you run it, it will print 1 2 3. See, first is 1, it first node, the first node when I was equal, means when that node was equal to first, it printed that node dot 1, that node dot data, which is 1. Then I what I did, then I made that node. This node is equal to node dot next, means this node dot next, which is second. Now then incremented it, then I went again, if it is equal to null. No, it is not equal to null. Sorry, it is equal while node is not equal to null. True, it is not equal to null at this point of time. It is equal to second, so print that value. Then again increment is, now it is 3. It's not equal to null. True, so again print the data. Now then increment is, now after 3, then it is equal to null. So node is not equal to, no, it is equal to null, so false. Then that's it. This is what it is happening. Now what I am going to do is, I will create a head. See, first, for example, we know which is head and which is first. So what I'm going to do here is, I'll make this first as a head. Node head head is equal to first. Okay, I made his head, made it head. Then what I'm going to do, first I'm doing I'm adding a new node in the beginning. So here it is 1. Now I'll make it 23, then 1 2 3, like that. Now let's create a new node. uh, Node, new node is equal to new node, new node dot data is equal to 23. Okay, then now what I am going to do, new node dot next, I will make it okay, new dot next, I'll make it to head. I will make it to first, and what I'm going to do, and I'll make this head, this as a head. Now because this is adding, I'm adding this node to the first, but that head is in the second node. Now when I'll add this to the first place, then this will become the first node, not the second node. So I need to make it as a head. So head is equal to new node, and what I'm going to do, node is equal to head. Yeah, so I will not take any reference of first, second, third, because it may vary. It won't be always first. So head is always, it is fixed. Head is a name that is always fixed, and we need to always compute it, always change it whenever we add something in beginning. Then we need to modify that, and we'll make the first node as a head node always. So here I have declared head node head is equal to first in the beginning where I have talked. So now what I'm going to do, now let's see if it is 23, it comes with 23 or not. See, now it's coming. Now 23 is the first node, then 1 2 3. So I have added this in the first. Now what I'm going to do, I will add a value which is called 24 in between 2 and 3. So for that, what I'm going to do, I will create a new here, adding 24 between 2 and 3. So create a new node 23, new node. Okay, so what I will be doing, node 23 dot data is equal to 23. Okay, then node 23 dot data so for that, what first we need to do, we need to traverse while node is not equal to while node dot data is not equal to 2. Try to understand what I am doing. Okay, so this node, okay, this is a node that we will take as a reference. We will put where we'll make this node equal to each node of a linked list. Okay, and we'll try to access those data and the next value of a node. I'm using this reference node we'll use. So node dot net, we'll use this node, and while node dot data is not equal to 2, means we need to stop, we need to add between 2 and 3, so we need to stop at 2. We need to make the current node as 2. So what I'm going to do, then I'll create a node, see your current is equal to new node. Okay, while node dot data is not equal to 2, not equal to 2, do this current is equal to node dot next, and node is equal to, so when what happens, see right now if node is in 23, so what I'm going to do, while node is not node dot data is not equal to 2, now the node data is not equal to 2, right? Which is true. So what I'm going to make, I'll make it like current, means current value I'll make it as 2 1. So then it will go, or else what we can do, why when node dot data is not equal to 2, because for example, if I make it not equal to, and if I make it current is equal to node, then what happens when it will reach to 2, which will tell which will make this false, and that node value won't get attached. Or else what we can do directly is, other apart from putting here, apart from putting this value, we can put this value as well, like while node is not equal to 3, current is equal to 2. So at last it will go till 2, only 2, up to 2 only it will execute. At 3, when it becomes node equal to 3, this will break. Okay, understood. So current is equal to node, then node is equal to node dot next. Okay, so at that point, at current it will stop. Current will stop at 2. Then what we're going to do, node 23, I have created this one, node 23 dot data is equal to 23. I have made that one as well, that new data, and node dot next. So what I'm going to do, node dot next, this value dot next is equal to, I will point this to 3 now. So node dot next is equal to current dot, which will stop at that point, current uh, current dot next, or else I can simply make it current dot next, means current will point at this one too. So this dot next is that only, right? So no need of current dot next, we can directly put it current dot next. So current dot next, which is node dot next, that node dot next is current dot next. And after that, what I am going to do, I'll try to put that current dot next as our node 3. Then current dot next is equal to node 23. That's it. Node 3, that it is. Okay, so let's try to run it. What just happened? Okay, see, let's debug it. Now let's see, let's try to debug it. Node is equal to node, new node. We have created this new node, and node is equal to head. Okay, that part we have done. Okay, so that's the problem here. So I need to make it node 1. See, they are using the reference here itself, right? So node 1, and what I'm going to do, I'll copy this part and I will paste here for another traversal. That was, see, that node was stopping at 2. So, and these were starting from the 2 itself. That's the problem. So what I'm going to do, I'll make it node 1, node 1. Okay, see now. See, 23, 1, 2, then 3, 23, then 3. Try to understand this part, okay? Just see and watch it. That same thing. Now, what we have done, using that same thing, we can remove them as well. Now, removing it. Remove 23 from starting. Okay, so to remove that, it's very simple. What we're going to do, we just need to shift the head from the 23 to this. So head is equal to first. That's it. Then what happens? Head equal to first. Then it removed. It got removed. See, it's got removed. You can just shifting it. So now that node is no more there, and you will just point it, and it will garbage collector will collect it. That's it. Simple. No more use of that. Then or else we can make that uh, then new node. Then what we can do, then removing that middle 23. Okay, so what we will do is at this point, that value, this value, this node is at 2, right? So we'll use this node only. You remove 23 from middle. So that node is in 2, right? In 2, so using that 2 only, node dot next is equal to node dot next dot next. What I am doing here, this now right now that node is here. You have used this while loop, right? This while loop, and this node became this node. Sorry, this node became 2 and stop there, because after that it was 3, and at 3 that become false. Then what I have done, node dot next means this node dot next is equal to node dot next dot next, which is 3. Okay, now let's run it. Okay. Wait. Okay, so what is happening here is okay, while node dot data is not equal to 3, current is equal to node, and okay, so it's not node, it's current. Sorry. So that node is pointing to 3. Node was pointing to 3, so we cannot use that one. So current is something that is stopping there. So same thing, it's not node, it's current. So now run it. See, 1, 2, 3. We have removed those 23 as well. So see, it may make you little confused, but it's very simple. It's just you are just instructing it. Go next, like that. It just you need to understand how many times and when and how many times we need to use next. When to use next and how many times we need to use next. That's the thing you need to understand that, and that's what you need to always think about it while working on linked list. After this, we'll solve some few simple questions that will make it more simple and more like easy to understand. Okay,